In this question, we're given the heating element of a water heater in an apartment building has a maximum power output of 28 kilowatts. Four residents of the building take showers at the same time, and each receives heated water at a volume flow rate of 14 times 10 power minus 5 meters cubed per second. If the water going into the heater has a temperature of 11 degrees Celsius, what is the maximum possible temperature of the hot water that each showering resident receives? So what we're interested in is the final temperature, with the initial temperature to be equal to 11 degrees Celsius, and essentially the energy given to heat up the water from 11 to this required final temperature is supplied by the power output, which is 28 kilowatts. I will convert this to watts, and essentially this is equal to the energy over time. Now the energy we're using here to heat up the water is the heat Q. So I can write the energy as Q. So I'm given the value of Q over T to be 28 times 10 power 3. We're also given that we have four residents and each is receiving water at a flow rate. Remember, the flow rate is basically the volume with respect to time. So the amount of water that is flowing per second. This is equal to 10 power minus 5. However, I have to account for each shower, and I have 4 in total. So we want the temperature. I can use easily the formula for the heat energy and how it is associated with a change in temperature. If I rearrange this for the final temperature, I will have T initial plus Q over MC. Now, I don't have the mass, and I don't have Q itself. I have Q over T. So what I will do is I will divide by T in the numerator and denominator of my equation. Now, one thing I notice is that I have M over T here, which I'm not sure what to do with it, but I can just write down M over T to be equal to rho V over T. So this gives me T initial plus Q over T over rho C V over T. You can see how I have all of these values. So T initial is 11 degrees Celsius. Q over T is the power, which is 28 times 10 power 3. Rho is just the density of water. C is the specific heat of water. And V over T is 14 times 10 power minus 5. Now, one thing I have to account for is V over T here is the total flow rate. So I have to multiply by 4 to account for all 4 showers that we have in this building. And if you calculate this, you will obtain 23 degrees Celsius for the final temperature after heating.